Hi all. In this video, we will try to understand the intricacies and the spree of build tooling of what happens when you actually run the command EKS anywhere create cluster. And for the next 15 to 20 minutes, the whole effort and the spree of build tooling and activities that happen till the point your cluster is fully created. On the screen, I think, just a quick recap. EKS Anywhere is the build tooling to provision EKS distro-based clusters on virtualized or bare metal environments, right? And together they are also called as EKS Anywhere clusters. But essentially, these are the Kubernetes clusters that run EKS distro, the same distro that runs in public cloud via the EKS service, and on-prem or unmanaged co-located facilities. This is what you use to actually provision, this. So let's understand, as I said, there's a lot of tools that are actually, bundled up to create a single terminology called as, EKS Anywhere. This is what where the magic happens actually. So let's see what happens in a sequential, method. We will do some bit of reverse engineering on this, and starting with the fact that, if let's say there are multiple cloud providers, right? AWS, Google, Azure, vSphere, many others, right? And they essentially all expose their infrastructure as a service via, the cloud provider APIs. So there is a concept called as, or let's say, if you have to think of a method that I can uniformly talk to these cloud providers, via their APIs and ask them all these questions. Hey, cloud provider, give me a set of virtual machines with a specific set of configurations in terms of, the operating system, the size and the, resources of those particular virtual machines and whatnot, right? In the case of public cloud, for example, AWS, which VPC, which security group, this, that. For vSphere, it could be, the same thing could be interpreted as, this is the data center reference in terms of the object hierarchy. And in that, give me, n number of virtual machines with this kind of resource configuration and the network attachment and all that. So point is that, can there be a uniform method to do this? Because the end cloud providers are different. They all have their different APIs, and but I still need a uniform method to do that. And let's say, for a while, just let's assume that, we are able to streamline this uniformly. Then can I also speak to those via the same APIs to these, IaaS routines that once the virtual machines are created, can we add some more Bootstrap routines to kind of, bring up those machines and convert those machines into Kubernetes nodes, right? Because essentially we will have to load the kubelets and the other software packages, So having a virtual machine doesn't make any sense. I mean, unless, you have the Kubernetes stack loaded on them, right? Depending upon the role that they would play in the cluster, right? Control, etcd, worker nodes and all that. And then, see, I'm just trying to kind of portray, and so many other questions, right? Okay, so once the nodes are up and running with the Kubernetes configuration, can I get the operational details of those resources so that I can understand, do health checks and things like that on those cluster nodes and things like that, right? So can you give me, cloud provider, can you give me the set of operational details of those resources? Likewise, once the Kubernetes cluster is created, essentially Kubernetes cluster creation is what, right? The virtual machines, the OS images with specific distribution of Kubernetes. And then I attribute the, as per the node roles like cluster, control, worker, and etcd. I render those attributes, and then some other software packages like CNI, CSI, everything actually loaded. And this combined together, all these set of resources is called a Kubernetes cluster. So I'm asking for the virtual machine with a certain size of configuration. I'm actually adding some Bootstrap, routines. I'm asking the cloud provider for some operational details. And then let's say on an ongoing basis, my operational requirements might change, right? The cluster size in terms of configuration and resource capacities, all that might change. The Kubernetes version might change. So can I talk to the underlying APIs to do those changes in the machine, right? Hey, cloud provider, there are some changes in my resource requirement. Can you please do the needful, right? And lastly, we want to delete the resources It could be either a intentful delete, or it could be via an upgrade where you create new nodes in terms of resource capacities, and the previous nodes get deleted and whatnot. So essentially, these are the asks, and these asks basically translate to some API calls to the cloud provider APIs, right? And all these are the cloud providers, including vSphere in this case. Now, point is that I don't have to build separate, methodologies to actually talk to individual cloud provider. This is where an open source project called as Cluster API fits in. Okay. Now, I don't want to go into the, so there's a lot of documentation. There's a Cluster API handbook that you can actually see. So in this video, we will try to briefly overview what is the role of Cluster API, and specifically from a EKS Anywhere basis, right? And Tanzu also uses Cluster API. There are many other Kubernetes, let's say, orchestrator in terms of, building Kubernetes clusters. A lot of, these use Cluster API. But essentially, Cluster API creates this uniformity in terms of, talking to the cloud providers, any of these cloud providers. So Cluster API is well known in the industry, and it supports many different cluster cloud providers. How does it do so? So it has a core set of components, plus every provider out there has, created the extensions, let's say that, right? So the core components, that's the Cluster API, and then the provider specific Cluster API components. So the open source community will maintain this, and each provider will maintain this. Together, I can, if I make it a 1 + 1 2, then it gives me this capability to actually feed in my requirements into Cluster API. Okay, and then via the specific constructs of individual providers, I can derive these kind of requirements and then pass them via the specific cloud provider APIs to, and talk and do this, whatever is printed here, ultimately to create a Kubernetes node, right? Again, as I said, provider specific Cluster API components are maintained and managed by every individual or respective, So for example, in the case of vSphere, it will be called as, this is called as CAPI, CAPI, and this will be called as CAPV, okay, CAPV. Likewise, if the underlying infrastructure service provider is AWS, then CAPI and CAPA, let's say CAPA, right? So you can understand, and these are all GitHub projects. Actually, you can go to the respective GitHub projects if you are into, so obviously this video is intended for as a broad-based audience. If you are a developer, you understand the, how a specific set of components is created. Most of them are written in Go, and you can understand how these APIs and resources are created actually. Point is that to install or to use Cluster API, you need a CLI, cluster and cluster CTL or something. Yeah, cluster CTL. So there's a lot of, you can do all this manually, okay? But let's progress, and I'll tell you what actually happens when you deploy EKS Anywhere and how these things are kind of, automated and things like that. But understand the relevance of these two terms, Cluster API and provider specific Cluster API components. They help in building these uniformity in terms of seeking, the execution of this via the infrastructure as a service APIs actually for many cloud players. So let's now talk specifically in terms of vSphere, because we are trying to deploy EKS Anywhere on vSphere. And in that case, if you look at this, right, the infrastructure as a service provider is vSphere. vSphere has its own APIs, plus VMware has also built its cluster API extensions for vSphere, which is called as CAPV. So you have the core cluster API and you have the CAPV. So in this case, what will happen is basically all these questions or these execution routines will be directed to vSphere APIs via the vSphere specific cluster API components. So I hope you're trying to kind of get a warmth in terms of what we're trying to get to. Now, point is that essentially these are software components, right? Cluster API and the the provider specific or the vSphere cluster API components. These are software components. The point is how and where they are run. How do you install these things? Where do you install these things? How do you run them? Are they deployed on a virtual machine? Are they deployed where? And things like that. So cluster API and the whole paraphernalia in terms of the ecosystem of components, they are essentially right from they're cloud native in nature. So they're like born in the cloud native sense section. So they were instituted to be run as containerized applications itself. Okay. So the ease of actually running these components as containers gives the flexibility that I can actually, they are portable in that nature. I can run them on any Kubernetes compliant Kubernetes container, right? I mean, compliant Kubernetes platform. So in this case, what would happen is basically, to avoid this chicken and egg, see, I am creating a Kubernetes cluster, but I need a Kubernetes cluster to run these components, right? And the easiest way to do so is, I don't want to create another Kubernetes cluster and then create this. So I can do a temporary Bootstrap cluster on any machine, which can run a kind of cluster which runs inside of a Docker container. Okay, and and in this case of EKS Anywhere, what happens is basically I load up this particular Kubernetes cluster, which is essentially a kind cluster running on a Dockerized system, which in this case will be the EKS Anywhere administrative machine. Okay, let me just again point out, this will be loaded on the EKS Anywhere administrative machine. So when we give the command, create cluster through the EKS-CTL Anywhere command, a Bootstrap cluster is spun up. And then EKS distro, a minimal footprint of that is basically loaded in this. So this becomes a proper Kubernetes cluster running this particular distribution of Kubernetes. And on that, we deploy the cluster API components, both from a core and vSphere perspective. And they are essentially deployed as what? They run inside of a specific namespace, and they run as pods, which are actually controller pods. Okay, so the entire software execution and workflow is rendered as a controller. Okay, so you have the cluster API vSphere controller, which is for this specific portion of the vSphere. Then you have the core controllers actually in terms of cluster API controller and the KubeADM controller. Again, point is that while we can get into the level of comprehension, it is beyond the scope of this video. For now, understand that this controller is responsible to actually translate or direct any queries directly, or interpret it, translate them to the respective. So this is vSphere, this is also vSphere, right? So this controller understands how to talk to vSphere via the APIs and all that. These are the two core components of the cluster API. The KubeADM is basically a Bootstrap, controller that, once your nodes come up and all that, it's a typical process of actually, rendering all the Kubernetes stack on the end nodes and all that. So these are the three core controllers that run on this particular Bootstrap, cluster, which is of the kind running EKS distro. So essentially, these are software applications bundled as a containerized workload, doing something. And what that something is, what we will now talk about, right? Essentially, they are running in a certain namespace of this kind cluster. So we try to answer this, right? So you understood the part here. Now, the point is, how are these API? See, essentially, these are API calls, right? Give me X virtual machines with Pi configuration, add some routines, essentially CRUD operations, create, read, update, delete, right? I mean, on API, communication. So how are these APIs constructed? I mean, calls constructed? What is the type of data and the source of that data that flows through these APIs, so that, vSphere can do the necessary, right? And also some other things that need to be done, they can be done, via the stack. So understand this, that when we are on the EKS Anywhere administrative machine, you have this kind cluster running there with EKS distro and these controllers. The command to create the cluster is just one, right? I mean, EKS-CTL Anywhere create cluster -f and a YAML specification. So let's look at this YAML file, and I'll tell you basically, in that context, for example, I'm just showing you a cluster sample, and I'm not going to go into this detail right now. I've already written a blog about it that you will actually observe in the following articles, which talks about the construction of the template exactly, right? But understand, for example, you can see that there is an API here, right? Anywhere EKS, Amazon, AWS.com. The kind of resource being created. So this is a CRD, right? Custom resource. The kind of resource being created is called as a cluster. Okay. And it is actually provisioned under the type of CRD being, anywhere, EKS anywhere CRDs. The second type of resource being created here, is a vSphere data center config. And you can see that this is a YAML file, essentially, okay? And this is a resource set, right? From here to here with some values in it. Likewise, there is another resource set of the type vSphere machine configuration. Can you see this? Yeah. So vSphere machine configurations, and again some bit of, and this essentially is for control plane. Likewise, for worker nodes, I have another, but the resource type is the same. It's a custom resource, but of the same type. vSphere machine configuration. It specifies, again, data store, disk requirements, which is the OS template that will be running, and number of CPUs and whatnot, right? In the cluster, basically, I'm specifying the count here, right? Count of the worker nodes, then count of the etcd nodes, and so point is that there is a custom resource called as cluster, and then there is the custom resource called as data center config, and then there is a custom resource called as vSphere machine config, which is actually repeated for defining 3 different types of nodes: control, worker, and etcd. Okay, so if you understand, this is the YAML template. Let me go back to so we are using this template, to create or direct the creation of the cluster here. So essentially, this is the YAML that we saw. It has the cluster spec, the data center reference configuration, and the vSphere machine reference configuration. Now, in the sense, you have the controller, okay, listening to all the incoming requests, and then trying to kind of modulate these requirements to the here in this case vSphere, via these API calls, and these would be different kind of API calls. But to get from this YAML all these specs and then translate into the resource requirement, essentially this YAML you saw were also they were essentially CRDs actually, or custom resource requirements, right? So what happens is that YAML is translated once we issue the cluster creation command. That YAML is basically translated into a set of CRDs, okay, which are basically then resident in a namespace within the kind cluster. Okay, so it's like having pods and some custom resources running here. Okay. And that's what I said, that based on these YAML inputs, CRDs are created. So these are the CRDs, and each CRD basically is of a different type and kind and all that. And while there are the ones that that we saw, cluster and vSphere data center config, machine configs, there are some additional CRDs also get generated as a part of the sequential process actually, which are related to cluster API related resources and some of the operational level APIs and CRDs in terms of machine health checks and all that, because you have to maintain the state of the cluster also, right? So additional CRDs are also created, which talk about individual virtual machine in the cluster node and all that actually, which will be created. So, but for now, understand that the cluster API, okay, installed as on a EKS distro loaded kind cluster, runs as a set of controllers, okay, and the requirements are expressed or maintained as CRDs, right? So this is essentially a Kubernetes cluster of a sort, right? And there are software methods that will do something. It's an application of sorts. It's not your typical web service application, but it's a like an enterprise or an end user application, but it's an application running on a Kubernetes cluster. The goal of this application is to basically create Kubernetes clusters on different infrastructure as a service provider. So now Since we have this, what will happen is basically these particular controllers, cap P and cap V, they monitor the change in this CRDs. So when you create a cluster, basically, it triggers a change in the CRD, right? And they actually take that particular CRD and then map it to the resource requirement in terms of the API calls. And then those API calls are basically constructed and then made to the infrastructure as a service provider. In this case, it's vSphere. Again, like I said, if this particular core remains same, which is the core API, core cluster API components, if this was AWS, the cluster API provider specific component would replace the vSphere component. So it could be AWS, in that case. So then the API call would talk about, this VPC, this type of node, EC2 instance, and everything else basically, which is specific to AWS. Here we are using the provider specific, component as vSphere from a cluster API standpoint. So necessarily all the API calls will, take the requirement and translate into a vSphere terminology and resource hierarchy and object definitions and all that. Do the API calls, and then what follows is basically the routines that are defined here, right, at a high level. Now that's what leads to the creation of the Kubernetes cluster. Okay, so basically you have taken the cluster definition. So see, providing for the vSphere machines only, right, saying that I need 7 machines, for example, 3 etcd, 2 worker, or 2, so 7 machines, right? Those machines have no value unless you bundle it with additional software and the Kubernetes components and everything, and basically you track it as a cluster, right? So this becomes, right now the cluster is assembled, I would say, right, not fully created, because the control plane nodes have been created, worker nodes have been created, etcd nodes have been created by these API calls, of course, and then the EKS distro is being loaded or has been loaded on top of that. Plus the CNI and CSI will be also installed as a part of this procedure, bootstrapping procedure and all that. So point is that right now the cluster is assembled, but there is some more steps that happen actually, and I will speak about that. Now, once this cluster is created, this is a very important phase. Okay, this is where some of the important implicit things actually become more explicit. So this pods or the controllers, once the cluster is being assembled and it's ready in that sense of an interim state, these particular pods and CRDs, or the controllers and CRDs, what are these? These are essentially Kubernetes resource definitions, right? Is there a way I can transfer this from this cluster? This is also a Kubernetes cluster, and there is a namespace that runs all of this. Can I transfer these resource objects from this cluster to this cluster? And the question is, why not? This is also a Kubernetes cluster. This is also a Kubernetes cluster. And it could be any compliant Kubernetes. And in this case, in fact, they both are running the same distro also. It need not be a necessity, but in this case, it's the same distro. So why can't I take these whole set of resources and transfer it to this particular cluster? And I'll tell you basically, what will happen. The term here is self-management, and I'll tell you what it is, in a while. Now, what will happen is basically, as far as this is concerned, once the cluster is kind of assembled and ready in that interim state, or fully ready with the API server loaded and all that, and you can do whatever you want, these set of resources are transferred from this cluster to this cluster, which is your actual workload cluster, right? And then the Bootstrap cluster is deleted. Okay. Once the Bootstrap cluster, once these resources are moved out to this cluster, what is the need for this Bootstrap cluster? There is no need for it. The cluster is already created. So we delete this particular Bootstrap cluster. Okay. So now you can see that, the cluster API, this particular cluster now has these, controllers and, CRDs and whatnot for this cluster itself, because these CRDs have the resource requirement or the resource definition of the cluster itself, right? And they are all running in a namespace within this cluster. And then an additional controller while this happens, and the move happens and the bootstrap is deleted. At that stage, EKS Anywhere basically, an additional application, let's say set is installed, which has EKSA controller, which is beyond the cluster API components and the CRDs, and a set of CRDs for, in association with these two. So what is the job of this EKSA controller now? Okay, now the cluster is ready, the bootstrap cluster is deleted. If I want to change the spec of the cluster, okay, let's say I want to increase the size of worker node from 2 to 4. Okay, how do I do that? There are various ways of doing it. I can use the EKSCTL, command, EKSCTL Anywhere, and then I can also use GitOps pipelines. Okay, or I can use a standard kubectl on this cluster itself, saying change. And what will I change? I will provide a new YAML, right? A new YAML that has a different count of the cluster nodes. Or maybe the resources of a specific type of node, like a worker or a etcd or a control plane. I might change that. So what will happen is that change, who's listening for those changes? So this EKSA controller provides the endpoint to listen for any further changes coming, either through whichever. So essentially, how do you engage or enter into a so this is the controller that runs that endpoint within as a software, as a Kubernetes pod, of course, right? So controller. And when you are doing EKSCTL upgrade cluster in terms of whatever resources, Kubernetes versions, this, that, whatever, the calls are actually listening. The calls are heard by this EKSA controller, and in association with these CRDs, what it happens is these CRDs are undergoing the change, right? So these CRDs were what? Machine configurations, cluster configurations, and things like that, right? For this target cluster itself. Earlier, they were residing on the Bootstrap cluster, but now they are on the same cluster in a certain namespace. But essentially, when the EKS controller, hears those changes, these CRDs will get updated. What will happen if these CRDs get updated? These controllers will take over, right? Saying that because I've been maintaining the state of this cluster via the state of these CRDs, the controller will detect that there is a change in the requirement because the CRDs have changed. And then the same thing will happen. It will start issuing those necessary API calls back to vSphere. Remember, it's like, it's a while loop in that sense, right? I mean, think of it, right? It's magical. You have something living in your cluster, and then you are asking it to rebuild your cluster, from within actually. So it's really good. Now, as I said, EKSA controller listens for those changes, detects that there is a request to actually change something, changes, or these CRDs undergo that changes based on the YAML provided now, the new YAML. These CRDs undergo change as such as, so when these change, the controllers detect that there is a change, they pick up those changes, translate them into the, provider specific calls, API calls, and then talk to vSphere again. And vSphere again, let's say, you want to change the vCPU and the memory on the cluster node. You need a new virtual machine. Yeah, so the new virtual machines are created, same process applies. Or it's a new worker node or a control plane node. So new machines are created and all that, and again, the new node. And then the reconciliation happens. That's a very important part of the entire loop here, right? The reconciliation that keeps happening at different stages. And there's a lot of moving parts here, right? So that reconciliation is the core and key as to what is the state of the cluster and what is the desired state in terms of these CRDs, right? So that maintaining that, and then any difference should be kind of reconciled, by invoking those cluster API actions. That keeps happening depending upon, how the changes are. So in a nutshell, you should understand, we had a Bootstrap cluster, now that's gone. Now this cluster is managed via itself. The cluster is managing itself. This is a layman language, but actually there is a cluster API, landscape running within this cluster to manage itself. Okay, very important. And we will be talking about this, from a actual practical observation. Now, this is theoretical, visual in that sense. I hope you get the point. But when we move on to the following articles where we actually create the cluster, I'll be showing you in terms of actual logs and the outputs of how this whole process is uncovering itself. That's very, and that gets even more technical. So if you feel this is a little heavy-handed, then I would say that gets a little more technical, but interesting. If you want to get into the weeds of it actually. So the point is now, at this point, this cluster is fully ready, and the cluster is deemed fully created, and now it can actually function as two, or it can perform two different roles or the same or whatever, right? It can work as a standalone workload cluster. So you can, there's a kube config generated for this cluster automatically, and all that SSH keys are generated, which will live on your EKS anywhere admin machine. And we will see that when you create the cluster in the following articles. But point is, you can use this as a standalone cluster now. Forget the cluster API part. You can deploy your applications and things like that. And changes to the cluster, again, I have mentioned that. Or instead of a standalone workload cluster, in which, in a workload cluster, I'm starting to deploy applications. And if I have given enough capacity to these, this cluster, you can deploy your, end user applications and whatnot. It's a cluster. You can start using it. Or alternatively, you can also use this as what is called as a different topology that involves a dedicated management cluster, and hanging off that dedicated management cluster are workload clusters, which necessarily are managed via central management. Now think of it, if I want to now create a new cluster, a workload cluster, so I can deem this, if I don't deploy end user applications on this, so this cluster looks very similar to the Bootstrap cluster. The only difference is that it's not a temporary kind cluster running in Docker. This is actually a full grade Kubernetes cluster. And in that case, it's a long-lived process. There are cluster API components. Everything is same as a Bootstrap cluster, but it's permanent in that nature. It's not ephemeral like a Bootstrap cluster. So, and there is a EKS controller and things like that. So now somebody, let's say from the EKS anywhere admin machine, okay, now the machine is separated out. This Bootstrap cluster it doesn't have. This is actually living separately. I issue a cluster creation command, but instead of saying that I need a fresh cluster, I can always say I need a workload cluster that is managed via a central or a dedicated management cluster. So I can point that EKSCTL create cluster command and the YAML template of it, the intended cluster being created, and then I can write it with an argument of kube config that points to this cluster. So what will happen is basically EKSA controller will get the requirement, a new YAML. The new YAML says, oh, the cluster, the vSphere machine config and the data center config, the cluster is a new name, which means additional CRDs will be created. Okay. For that particular cluster, not this cluster, for an additional set of CRDs which are named by that new cluster, and the vSphere machine configuration CRDs for that, and data center reference. So all the entire set of CRDs is now created for the new cluster. And again, the same, there are additional CRDs, cluster API will kick in, it will go back here, it will talk to vSphere. Only thing is, it will not do changes on this cluster. It will actually provision the virtual machines, but as a new cluster coming up. Right? etcd nodes, control plane nodes, worker nodes, all that, a new cluster. But who created this new cluster? Who actually invoked that whole set of cluster creation? It is a cluster API here on the management cluster. And in this case, I'm calling it as a management cluster. You can call it a standalone workload cluster if you start deploying end user applications. But I'm going to reference this as management cluster now because I will not deploy any end user applications here. So point is that who invoked the cluster creation for the new workload cluster? This cluster API. Where did it get the inputs from? From the CRD changes. Who added these CRD changes? The EKSA controller. How did EKSA controller get the input? Through a YAML coming in, so, and that YAML specified a new cluster basically. Now, when this cluster is created, the only difference between a standalone workload cluster, okay, or a management cluster, and this new workload cluster, there is an intelligence inside saying that, since I have created this cluster, okay, when I have been, this whole thing is living on a dedicated management cluster, I will not deploy cluster API resources on that new workload cluster. So all the cluster API resources and the clusters, the new clusters, CRDs and all that are centrally managed. If the workload cluster is created here, if I need a change in the resource count of this, I will supply the new YAML, the CRDs for that cluster will change, the changes invoked, vSphere is called upon, and vSphere creates those new virtual machines, and these virtual machines are upgraded or deleted or augmented, whatever. The state changes of this cluster, right? And then, sorry about that. So then, that state is reconciled within this layer actually, and those CRDs are updated, the state is maintained. And if you have 10 such clusters created, workload clusters, what will happen is 10 sets of CRDs will be created, one for each cluster. That will have the cluster as such, the kind cluster resource, then the vSphere machine configurations for that particular cluster, and all the references basically that align to that cluster. And you can keep adding clusters, 1, 2, 3, 4, 5, 6, 7, 8. And this becomes your central management, dedicated management clusters. And those are, managed workload clusters, let's say, right? And as I described, if you don't want to go through this topology of having management cluster and then, separate workload clusters, then you can keep creating these kind of standalone workload clusters. And in that case, basically, you can deploy your production applications. Only thing is the topology is a standalone workload cluster topology versus a management cluster, and then these, the workload clusters, which are managed workload clusters. So I think, what will be also interesting is to couple all this visualization with the actual cluster creation process that will happen. And I'll show you the CRDs and, in both the topologies, the controller actions and the CRDs in the standalone workload cluster and also the dedicated management cluster topology. Okay, so now the big question. Okay, the big question is, and I've kind of made it a little bigger here. Who's doing all this magical orchestration of creating the Bootstrap? We saw a lot of things that happened right till this point, of actually creating Bootstrap cluster on the EKS Anywhere admin machine, loading that EKS distro on that, installing cluster API components on the Bootstrap cluster, the creating that this cluster, then installation of various software packages that actually make up the cluster itself, right? And also the Bootstrap cluster components. Then all kind of reconciliations, moving resources from Bootstrap to target, deleting Bootstrap, adding these controllers. Who's doing all this, and in how? I mean, right? The answer is very simple. This is what is called as the EKS Anywhere software, which lives and breathes on your EKS Anywhere admin machine. Okay, and as I said towards the start, and I've been kind of talking about it, now you should be able to appreciate the fact that when I say EKS Anywhere is nothing but a open source set of integrated build tooling, because in the backend you see cluster API, you have to install it. The CLI for cluster API is cluster CTL. Talking to vSphere generally uses a different CLI called as govc. Plus there are other API calls being made to vSphere. Plus all of this, basically all that is called as an build tooling, and that integration when it comes together, is called as EKS Anywhere. And what it is doing, it is creating Kubernetes clusters based on EKS distro here. So point is simple, right? This is what you should now be able to comprehend, what the whole narrative is all about actually, right? Also, let's understand, since I'm mentioning and emphasizing on this integrated build tooling, how does the whole thing start actually, right? And I've kind of summarized it here, but point is that let me go to, this one. See, right now I'm on the EKS Anywhere open source, GitHub project. As I said, it's an integrated set of build tooling, right? So you can see, I don't want to get into the depth of it, but I'll show you some things which are actually important, right? There is a release, subdirectory here. And, in that release subdirectory, I can see that there is a alpha v1 API. This is the release spec. And these are the artifacts for that. Okay, so let's see what all artifacts are included. I have spoken to that visually. So, but you can see here that the versions bundle for EKS Anywhere will actually download all these or include all this. This is, you saw visually, cluster API core, then kubeadm Bootstrap, right? The cert manager idea. I mean, those are default components, cert manager. Then you can see provider specific API provider components. So you can run it on as a local cluster for testing purpose, right? On Docker also, or for vSphere, like we explained, or for cloud stack, Apache cloud stack. So this is a good, replacement for on-prem clouds based on, Apache cloud stack. For bare metal, the cluster, the provider specific cluster API components are Tinkerbell. Likewise, Snow, Nutanix, Cilium is the CNI, right? And this is the kind cluster, some specific portions of that. Then I also spoke to you about the EKS Anywhere cluster controller, right? Which once the core components are shifted and any further requirements and all that. Then there is a Bootstrap provider for etcd controller, and then the EKS distro also, right? So you can see that, there's a lot of, inclusion in that sense, right? And then the images that will be required to actually run those, components in the context of, if a specific infrastructure service provider is being activated, then the images required to run or to communicate, with that particular. So you can see a lot of things here, and also you can see, shared images like Bootstrap controller, kubeproxy, cert manager. These are all things that go on to make a Kubernetes cluster, right, on top of the EKS distro, right? So I don't want to kind of, bore you to death if you don't understand here, but at least you can read English here, in terms of what we saw visually and, how it translates to. Plus, I also want to emphasize, I picked up this particular, I'm on the same, EKS Anywhere, but I've gone a little deeper here, the machine template, right? See, here the package vSphere, basically, which is associated with a cluster API extension for vSphere. What it is doing, you can see getting the machine template. See, I came to this page for a reason, right? It is basically, trying to get the machine template, creating the Kubernetes client, and actually, and then trying to kind of retrieving that particular machine template from that context, and then trying to compare the state and all that. Then you also have this cluster.go. So I told you that, let's see hit here also the YAML file of where is that? Yeah, the YAML file. Yeah, this is the YAML file that you actually build to create the cluster, right? So the kind is called as cluster. Let's look at, this is a Go component, right? I mean, and essentially when you are saying that, you are listening to an API call, when you create a cluster, this particular component is being rendered, right? So you can see that, the cluster kind is a cluster, blah, blah, blah. And then this takes that YAML input, okay? So you can see that the cluster network in terms of the pod, services, CIDR blocks, CNI config, you can see it all here. Cluster network, CNI, pod, CIDR blocks, and all that, right? So You can see, compare it. This is the Go routine, the actual software routine that will run inside, when you create a cluster, translated into, this was a YAML, and this is the actual, let's say, execution of that in a context of EKS Anywhere. So the cluster spec it is narrating, and then, it will basically generate the options, and then at some point you will see cluster generate, right, with shared machine group reference, right? So it's basically taking the data center reference, okay, and the machine reference. What are these two functions? They are, the input to that is this data center config and the vSphere machine config. You see, this is what I was telling you, basically how it gets translated, the YAML, and the execution of that, with data center reference config, with machine reference config. So the function that will be executed is cluster generate, right? And the specs are also further listed as worker node group configurations and the machine group reference and all that. So I think point should be understood, right? I don't want to kind of burn you out with this level of. You can always go to this, EKS Anywhere's GitHub page. In the blog, I have also listed likewise the EKS distro. See, EKS distro is one of the components of EKS Anywhere. There are other build tooling, right? The point is, you can go to the open source project, GitHub project of EKS distro also, and see that in that what is included, the outside of the core compliant, 100% upstream compliant Kubernetes. So I think I'll come back to this visual here and try to kind of, it's been a long talk, but I hope that, you kind of got under the hood of, what's going to happen. And we have still more discussion that will happen when we get to the actual cluster creation. Yeah. So thank you for your time and patience, obviously. Cheers.